the series for cosine x. And of course, you can always differentiate,
Sin x.
or you can integrate. You can integrate this one to get the series for
-1. Or
negative log, negative ln 1 minus x, yes. Yeah, it's an easy way to do it. Okay, now, the question is, that's the last thing before the test. It's a big thing. Is when do these series converge? Because we are adding infinitely many things. So the question is, for what values of x is this the same as this? And this being going on forever? No, this, technically if you put x equal to 1/2, 1 plus a half squared plus a half cubed plus a half to the 4 plus a half to the 5 plus a half to the 6 is what? 2. 1 minus a half. 1/2. 1 divided by 1/2. 2. Certainly when x is equal to 2, this is going to converge. As if you say 1 plus a half cubed, keep going. Half to the 4 plus a half to the 5 plus a half to the 6 plus a half to the 7 plus a half to the 8 plus a half to the, keep going. You're going to get exactly that. 1 over 1 minus 1/2. How about x equal to 2/3? 1 plus 2/3 plus 2/3 squared plus 2/3 cubed plus 2/3 to the 4 plus 2/3 to the 5 plus 2/3 to the 6. Keep going. What is that going to converge to? Well, 1 minus 2/3. 1/3, 1 over 1/3. 3. That's going to converge to 3. Provided you go on forever. So what values of x does this converge? To the series here. And how about this one here? Can I put 1 in here? In other words, is e equal to 1 plus 1 plus 1/2 plus 1 over 6 plus 1 over 24 plus 1 over 120 plus 1 over 720? Is that going to convert to 1? So to e, let x equal to 1. Keep going. Is this going to convert to e?
So,
Huh?
I think so.
Yes. How about 2? I put a 2 in here, will it convert? I don't know. Well, this one here will certainly give you false. Huh? What if x is equal to 1? Oh, let's see. 1 plus 1 plus 1 plus,
3.
plus 1.
4.
Is it going to converge to what? You kind of put x equal to 1 here. So this is rubbish already. No matter how many terms you go, this is not going to converge for x equal to 1. How about 1.2? 1 plus 1.2 plus 1.2 squared plus 1.2 cubed plus 1.2 to the 4 plus 1. Keep going. You know you're going to get infinity. Because the terms are not going to 0 and you're adding them all up. Well, what if you put 1.2 here? What do you get? 1 minus 1.2. Huh? Negative 0.2. 1 over negative 0.2. Negative 5. Clearly it's not the same. Yeah. You cannot put x equal to 1.2. Cannot. They're not the same. So for what values of x is this the same as this? For what values of x is this the same as this? For what values of x is this the same as this? For what value of x is this. So we have an infinite series and we want to know, same if you have this. Let's say this. We have a series, this is 1 plus x squared plus x cubed, so 4. If I differentiate this, I'll get what?
1 over 1 minus x squared.
And if I differentiate this, I'll get what?
0.
Well, you have the series for this. Nice trick. And somebody asks you for the series for this. They say, well, hey, if I differentiate this, I'll get this. So if I differentiate this, I'll get the series for it. And the question is this legitimate? No. Depends on x. Because if this is this, and if you differentiate this, then you can differentiate this. But what does it mean to differentiate this? It means add these all up and then differentiate. Who's going to be able to do that? No human being. If this is the same as this, and if you differentiate this, well then you can differentiate this. But how do you differentiate this? You've got to add them all up. And then differentiate. Good luck with that. What we say is, why don't we differentiate and then add them all up? Well, now the question is that kosher? Is that legitimate? Depends. Huh? It depends. You can only do that where this converges to this. And where does this converge to this? Anybody?
Less than 1.
Huh?
Less than 1.
So x can be negative 5?
Or absolute values.
Right, because this is a
Power.
geometric series common ratio.
Less than
Common ratio. Common ratio.
x.
So if x in absolute value is less than 1, we're good to go. Clear. But this is only going to converge when x is less than 1 in absolute value. Anyway, so we have an infinite power series. And we want to know whether this converges. Huh? So you have your test there. Integral test, your comparison test, your ratio test, your limit comparison test, blah, 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 blah. But you tell me, what is the best test for these things? What is the best test for power series? Who listened to me?
Comparison.
Oh,
Geometric.
ratio test. You are going to be doing the ratio test. We want to determine the convergence of a power series. I don't know. I would say the first thing you want to try is the ratio test. If you want, you can change this to i's. Now these are your terms. I will call that AI. Okay. What is AI plus 1?
AI plus 1x to 9.
Because this involves x's also. I do nothing about that, I'm sorry. So for example, here, this is a power series about x equal to 0. Is that clear? Huh? Let's just say if you're looking at this function 1 over 1 minus x, I don't know. And you're looking at x equal to 0. You want to know how far from 0 can you go? What values of x can I put in there in the neighborhood of 0? Now the problem becomes, If you're on this side, x is positive. If you're on this side, x is negative. So I really need absolute values. I'm going to do the ratio test. Take the absolute value. Let us do the ratio test on this series here. M. I'm looking at this series. What is my AI? If you want, you can change this to I's. Nothing wrong with you. Would you like me to change this to I's? Mr. Harris?
Yes.
You would like me to change to I, not a problem. What is my AI?
X.
Huh?
X.
X to the I. What is AI plus 1? Now I take the ratio.